Well, on page 32. Not page 32, page 193, number 32. So this is the one where you were supposed to make those statements. If the statement is true, is write the converse. If the converse is true, then either by conditional. So
I do believe your projector is hot.
my projector. Okay. So it says, if a prism has bases with n sides each, then the prism has a total of 3n edges. So yes, with n sides. 3n edges. So that'd be a true statement. So then we have to do the converse. So converse is if prism has 3n edges, then it has n sides. And that's going to be a true statement. So the biconditional statement would be a prism has a prism width, I guess you'd say, with n sides if and only if it has 3n edges. Probably a better way to say it. A prism has n sides. N sides if and only if it has 3n edges. Okay. 34. So this is, it just says state the conclusion. So not P implies T, not P implies if you look back at what they're saying is, then you would write conclusion is therefore T, right? Says P, this is an if and only if, Q, and then Q, if and only if R, and that would imply, therefore what? P, if and only if R, would be a transitive statement. And then the last one, 38, says P implies Q, T implies Q, Q implies S, P, therefore what? S, right? Or you could say P implies S. That's a transitive. Okay. Next group of problems says for each statement given in problems 39 through 44, write the equivalent conditional statement if then form. So 40 says the height of an equilateral triangle with a side of length S is S over 2 square root of 3. So how would you say if equilateral triangle has height S, then has a length of side S, length of side S, then the height is S over 2 square root of 3. Okay. (42) says the only polyhedron with 4 vertices is a triangular pyramid. So what would you say? If polyhedron has four vertices, then it is a triangular pyramid, PY. Okay. So 44, how would you say that? You'd have to have if, right? Figure is cylinder. Then it is not a polyhedron. 46. So it probably should draw this out. So I got A, B, C. So first thing is angle ABD and angle DBC adjacent. And that's given to us. And then A, B, C are collinear. A, B, C are collinear. And that's given. And we're supposed to prove that ABD and DBC are complementary. So what would we do to prove that? So what would you say? I guess that they're given this set of adjacent, so their number one was that. Then their number two, I guess I should have looked at the thing. Their number two was angle A, B, D plus angle D, B, C equals angle A, B, C. And that's the definition of adjacent, right? So then they're saying three. A, B, C are collinear. So this statement up here, I was looking at what they were doing. This is three statement. And that's given. Then four, angle A, B, C equals 180. So what do we say there? Definition of a straight angle. Because when A, B, C are collinear, that's a straight angle. It's 180 degrees. What would you say for the next statement? Angle A, BD plus angle D, BC equals 180. What would you give for a reason there? It'd either be a transitive property or else you do substitution, because this thing right here is equal to this. This is equal to this. You could say either transitivity or else you could do substituting this set of angles for this set. So substitution or transitivity. And that's 6. And then it says therefore, and then you'd say therefore, because this is what you're trying to prove. A, B, D, and angle D, B, C are supplementary. And what would be the reason for that? Be definition, right? Supplementary angles. Because definition of supplementary angles are angles whose sum are 180 degrees. So that's statement and the reason for the statement. It'd be the typical way that I guess I would expect a proof rather proof by paragraph. This is the way that I'm accustomed to writing out a proof. So the next 48 says a bed of a pickup measures 8 foot 3 inches by 5 foot. You want to haul 9 feet lengths of pipe so that they lay flat in the bed of the pickup. How could you use deductive reasoning to determine whether you can lay the pipes in the bed of the pickup? So if it's 8 foot 3 inches by 5 foot, and you have a 9 foot pipe, can you lay it flat? What would you do to say that you can lay it flat? Well, you could say if I laid it diagonally across there, right? And just do a rough estimate of it. If you do that diagonal is what? How would you find that diagonal? It'd be the square root of roughly 8, right? A little bit over 8 squared plus 5 squared. So that'd be the square root of 64. That's going to be bigger than 64 plus 25. So if you did that calculation, if you did second square root of 8 squared plus 5 squared, it's 9.4. So what would you conclude? Lay the pipe down, right? As long as you didn't have so many pipe that it occupied, if you were just a few pipe, you could conclude that you could lay them down, but you would only have a certain amount, because once you laid the pipe across, you could only lay so many of them across, because then you'd run out of room to lay them. If you wanted to lay them flat in the bottom of the pickup. But you'd say, yeah, you could do it, as long as it's not a lot of them. So it says advertising slogans often use conditional statements which may or may not include the words if then. Sometimes the conditional is implied. Restate each of the following in if then form. Decide if the statement is true or false. Write the converse and decide if the converse is true or false. Justify your responses. So the A part says, choosy mothers choose Jif. So how would you write the statement in an if-then form? If what? If choosy mother. Mother. Then by Jeff, right? So would that be a true statement? Well, it could be, right? You could say true. Now, the converse. So the converse would be if by Jeff, then choosy mother. Well, the question is, the first one you could say, choosy mothers may buy Jif or they may buy other things. But, they would buy Jif over other peanut butter. So that would be probably a true statement. Of all the peanut butters, they would buy Jif. But now this one says, if they buy Jif, then choosing mother. Is that a true statement? What do you think? I guess I wrote Jif wrong. J-I-F. My contention is I think that would be a false statement, because buying Jif is not the only criteria for being a choosing mother. You could the first one you could say, if that person's choosing mother, then of all the peanut butter, she's going to buy a Jif. But if they buy Jif, it's not the only criteria for being a choosing mother. What do you think? Think it's true or false?
I think it's true.
Okay, if you said it's true, then the statement, let's see, the by conditional statement. I don't know, did they say that right? Converse, decide if the converse is true. Just, they don't say right the by conditional. So the B part says, if it says Libby's on the label, you will like it on your table. That's a jingle that have you heard that? I mean, never heard it. No, that was something like that. So if it says Libby's, it was all of these were jingles at one time on the label. Then you will like it, right? You will like it on your table. What do you think? True statement? Yeah, probably. Then if you like it on your table, like it on your table, then it says Libby's on the label. What do you think about that? I mean, that one, I would more say that one is false. So, C. So, if you don't get it, you don't get it. So how are you going to write it? If you don't get it, then you don't get it. That sounds like a Yogi Bearism, right? You know, that could be true, and the converse would be true. Yogi Bear was, you know, like it isn't over until it's over. Make statements like that. Okay. So the next section, 4.2. On 196, it's going to tell you about congruent triangles. So if a triangle is congruent, and the thing you got to make sure that when you write these congruent triangles is that, let's see, if you have a pair of triangles, and they're labeled A, B, C, D, E, F. And if those two triangles, if the triangles are congruent, and then if they were congruent by just visual, you would say this one and this side are congruent, this side and this side are congruent, okay, two of them, and this side and this side are congruent. And then the points, you know, the A corresponds to the E, right? And the B would correspond to the D, and the F, C would correspond to the F. So when you write these triangles, that they're congruent, and you write triangle A, B, C. So point A corresponds to E, and B corresponds, and I should write it over, to D, and C would correspond to F. So if you write A, B, C, then you better, when you say they're congruent, you say triangle E, D, F. Make it so that those letters correspond. A and E, see what I'm saying? This one corresponds to the first one. The B corresponds to the second letter, and this one corresponds to that one. So yeah, it's not right to just write the triangle like the second triangle to write DFE, or, you know, because then you're not showing the correspondence. You understand what I'm saying? You want to you want to write the corresponding vertices in order. And then if this is the case, then the angle at A would correspond to the angle at E. The angle at B correspond to the angle at B, and C would correspond to the angle at F. And be sure that you get those correspondence right. You know, I might not have drawn it the same way I drew it, obviously backwards somewhat, so that you would see that it's important to make those points correspond. The reflexive property underneath that in 196, it's just saying that a triangle is congruent to itself. And you can do that with any side and any angle, anything, that it's congruent to itself. Like AC is congruent to AC, or angle A is congruent to angle A. That's reflexive. Symmetry says that if you have the first triangle congruent to the second triangle, then the second triangle is congruent to the first triangle. That's symmetric. And then transitive would be if you had a third triangle, then if your first triangle is congruent to the second's congruent to the third, then the first is to the third. And that transitivity works for anything, angles, sides, whatever. So the reflexive, symmetric, and transitive laws apply, and definitions apply. In 197, it's talking about congruence, the side angle side congruent. And the postulate says if two sides and an included angle of one triangle is congruent respectively to two sides and the included angle of another triangle. Now, if you remember from geometry, when they go side, angle, side, that angle has to be between those two sides. It's when you write that out, you're saying that specifically. And what we're going to find is that also angle, side works, because if you know two angles of one triangle congruent to two angles of another triangle, then the third angles are congruent. And then you have, from that, you have an angle side angle, which is a congruence. And then another congruence is side, side. This one is two angles and an included side. This is the side and two angles that are not included between the side. And then this is three sides. Two triangles that have congruent angles are not congruent. Not congruent triangles. These, when you have this situation, you're going to have congruent triangles. We'll look at that more a little later. But this postulate 4.1 is the side angle side. And then the theorem 4.2 is then two legs of one right triangle are congruent respectively to two legs of another right triangle, then triangles are congruent. That's actually a special case of this particular one right here, because if you got two legs so if you have two legs of one triangle congruent to if this one is congruent to this one, and that one is congruent to that one, those are the legs, and it's a right triangle, then what's true? You know that these angles are congruent, and therefore you have a special case of side angle side. And then theorem 4.3, it's saying you have two triangles where you have the hypotenuse and a leg. So if you had this hypotenuse congruent to that hypotenuse on a right triangle, this leg congruent to that leg on a right triangle, then you would know this angle, and you would actually be able to calculate the third side because of the quadratic equation. You could actually calculate it. This side would be calculatable because you know the hypotenuse and the side, and therefore you could show that the third side is congruent, and then you'd have side angle side. And then there's postulate 4.2, two angles. That's two angles and an included side. That's this one. The congruent, respectively, two angles of an included side of another triangle, and the two triangles are congruent. And then like theorem 4.4, it says the converse of the Pythagorean theorem, the sum of the squares of the lengths of the sides of a triangle equals the sum of the third side. Then the triangle is a right triangle. The square. Okay. How's that the converse? What does the Pythagorean theorem say? A squared plus b squared equals c squared. The sum of the squares of the lengths of two sides of a triangle equals the square of the third side. So what it is that's the converse, because the Pythagorean theorem says if you have a right triangle, then the sum of the squares of the length of two sides of a triangle equals the square of the third side. This is the converse, where it says the sum of if the sum of the squares of two legs is equal to the square of the third, then it's a right triangle. So that's why the statement of the converse is there. Okay.